Welcome to Post AGI. I'm your host Soubhik. This show starts with a simple premise. The AGI debate is the easy part. The harder questions are everything that comes after for capital, for governance, for labor, and for the world that we'll have to live in. Each episode of this show features a long form conversation with someone thinking hard about one of those questions. Let's get into it. Today's episode is about a question that is becoming extremely important to human society. As AI scales, what happens to labor, firms, markets, and the institutions that make an economy work? A lot of the conversation around AI still swings between two extremes, utopian abundance on one side and mass displacement on the other. But our guest today argues that the real bottleneck may be something else, is the verification infrastructure. Joining us today is Christian Catalini, founder of the MIT Cryptoeconomics Lab and previously associate professor at MIT Sloan. We'll use his recent paper, Some Simple Economics of AGI, as a lens to explore where humans remain valuable and why verification may become the scarce complement to AI, and what kind of policy, governance, and market design will shape whether this transition leads to fragility or to genuine abundance. Christian, welcome to the show.
Thank you for having me. Looking forward to the conversation.
So I want to kick off our conversation by reading a few lines from your paper that to me capture the heart of this debate on what can go right and what can go wrong if we proceed with AI automation without the right safeguards and verification infrastructure in place. So let me read these few lines. Ultimately, the frontier of automation is not an exogenous force. It's a reflection of our institutional choices. We face a stark divergence, succumb to a widening measurability gap, and drift into a hollow economy, an infinite sprawl of machine execution we can neither understand nor underwrite, or aggressively scale our capacity for ground truth in step with the power we unleash, converting this cognitive acceleration into the profound engine of discovery, experimentation, and verifiable abundance in human history. So, to be frank, the first part of this excerpt paints a very grim picture of where society could end up if automation scaled faster than our capacity to verify and underwrite it. So can you unpack what a hollow economy might actually look like in practice for workers, firms, and institutions?
Yes, let me start with something quite timely as we're recording this podcast together. There's news on X of Amazon calling an emergency meeting across a number of engineering groups. They suddenly realized they were shipping slop. We heard the headlines, right? A lot of tech companies have been increasing the share of code that's generated by AI. But inadvertently, of course, they're shipping code that they haven't fully verified. Some of that is inevitable. The potential and the capabilities of these models are so magical that the first temptation is just to use them to their full potential. But if we're not careful and if we don't put the right infrastructure in place, there's really a stark divergence. On one side, the cost to automate things is going to zero for a lot of activities. But on the other side, there's something that's still bottlenecked by our human nature, which is the cost of making sure that that output really respects our intent, respects our direction, our guardrails. And so, code is probably the first one to be impacted because it's so salient and the models have been fine-tuned to do amazing work on the engineering side. But I think it's going to perpetrate and percolate through many areas of the economy. We are now shipping economic output that we don't fully stand behind. We don't have the bandwidth. We stand behind every single line, every single word of text, every image that might be generated by one of these models. And so because these models are optimizing often on the metrics they understand, on the metrics that we gave them, there's a classic situation that we've seen over the course of history many times. Many of you have probably heard of Goodhart's law. When a measure becomes a target, it ceases to be what's the insight behind it? It's the idea that sometimes we will pick a metric as something that we want to push, a KPI, or some stat on a dashboard. And at the beginning, maybe we may not think about the side effects of just picking that specific metric. A metric is by design a reduction in dimensionality. Problems are complex, and because complexity will slow us down in day-to-day, we kind of try to condense it to its first principles. But if we don't pick the right first principles, we may end up optimizing for the wrong thing or creating some major side effects. So it's not necessarily that some of these agents may be malevolent or if you've read enough sci-fi, trying to take over our processes at this stage, but they may just be inadvertently optimizing for proxy metrics. So not the actual thing we want, like stable code that can achieve a goal, but something that looks and feels like the real thing. There's a famous clip in the Silicon Valley HBO show where essentially the AI agent decides to delete all the lines of code because that's the best way to remove all the bugs. That's a classic example of the hollow economy. Your metric, is perfectly hit. All the bugs are gone, but of course the intent is also zero because now you have no code base and no software to work.
So why not just put more humans in the loop? Just they should check it. Like, isn't that the easy answer here? Or is there there's something more complicated going on?
So part of it goes back to basic economics. In some cases, yes, you could put the human in the loop and verify every single line of code. It's not that we don't have the technology to do that. It's just not economically feasible. And the whole point of automating, for example, code production is to move faster and reduce cost and kind of increase the shipping speed. If you now, verify every line, you're back to kind of the old regime and you lose most of the gains. So the real answer is really to think through what kind of verification infrastructure, what kind of tooling can we bring into the picture so that, look, yes, we're going to deploy AI, we're going to deploy it at very fast speed, but can we ensure that as AI capabilities increase, also our capabilities to steer it, to keep it within the bounds, and to programmatically control it, improve over time rather than decrease over time.
So just going back to the example that you were saying about the today's AWS thing. So AWS, they fired a lot of people. So shouldn't they have thought about this? Hey, just retain these people, retrain them, maybe upskill them. Isn't that what their firms, like I'm just taking AWS as an example, but any firm's responsibility towards shipping a good infrastructure will be just upskill their existing employees and have AI automated, but humans are in the loop to do some kind of checks.
I think many companies are already thinking about this. And, if you talk to senior engineers, they're both excited and terrified about what's happening sometimes at the junior ranks. Yes. Look, part of this is not necessarily something that companies are not aware of, but of course, we're early. The subtle problem with all of this, I think, is that sometimes that level of systemic risk accumulates behind the scenes. In the paper, we have this example from the financial sector where there was a very clever hedge fund, long-term capital management, that for the longest time, was founded by some Nobel laureates and top people behind it. It was performing extremely well in the market until it kind of crashed and burned. And in a sense, it had accumulated all these tech debt behind the scenes without anyone realizing it. So some weird edge case triggered, of course, the whole cascade. Yes, the story could have gone differently, but I think we're going to see many of these instances where it's a bit like the story of Chernobyl. Complex system failing in complex ways. We introduce code, we don't fully understand it, and if we're not careful, some weird cascade of events could be fairly catastrophic.
So in the firm case or as an economy, if they are putting emphasis on verifiability as some kind of infrastructure, does that require the firm to slow down on the automation? Like, how does the firms? It's a barbell strategy, right? On one side you have to automate, on the other side you have to probably put some kind of verifiability, and as a firm I'm racing with other firms also. It's like all prisoner's dilemma going on. I want to capture more of the pie. So how does the firm decide like where to put emphasis on? Like, it's not their responsibility is to make more value for their shareholders, and verifiability is an afterthought, which AWS incident is showing up right now. They're asking some kind of senior engineers to do it. So
not always, right? So I would argue that actually smart founders and CEOs and executives across the board will recognize that the long-term reputation of the company relies on shipping code they can stand behind. The other interesting trend is some startups are already kind of trying to insure these systems. A few weeks ago, an audio model, for example, started adding insurance so that if the audio model is deployed and does something that's out of bounds, the company can kind of make their customers whole. We call this liability as a service, kind of moving from software as a service to liability as a service, where you need to be able to stand behind not just the code, but also the output, the work. It's a very exciting time. To some extent, we're transitioning from software as a service to labor as software. Companies will be able to deploy pretty much an agentic workforce that will take many tasks that typically would have been bottlenecked and kind of executed by people. Those people can focus on kind of the IL level steering and verification, and the companies can do a lot more with a lot less.
So in the liability as a service, is it more like checking the output is complying with the intent, or does it also check all the execution, like liability towards that execution is also correct, not just the output?
I would say this is actually where crypto infrastructure comes into the picture. The crypto sector, to some extent, has been building provenance, verification, and identity infrastructure for more than a decade, with different ranges of success, and to some extent, no commercial application of a lot of the really good ideas that are being floated in this space. Companies, I think, will start realizing, one, that they can develop tools that empower some of their top talent to verify agentic output even before it's kind of lands in production. Second, they'll be able to keep track of how the model performs and kind of, the signals that come, the telemetry, if you want, of the system in place, and adjust along the way. And third, they will use all of that information to really come up with a model. Ideally, as you scale, as you get more data, as you get more customers, as more information flows through the system, you can make the system more and more reliable rather than less so. We call these verification grade network effects. What's kind of interesting in a world with AI is that a lot of the traditional network effects that used to defend platforms are gone, right? Agents can populate listings, they can do a lot of search, they can do matching. Many of the frictions that we used to, when scaling, say, a digital platform, can be reproduced at a low cost. But verification grade network effects are kind of the opposite. Companies that really use scale, use better data, better historical data. There's also an area where some of the incumbents to some extent have an advantage, right? So if you think about large financial institutions, large payment networks, they have a history of failure. They know a lot of edge cases. They know a lot of the behaviors that fraudsters and others may kind of take advantage of. They can train better models that lower the cost of, say, delivering a payment. But more generally, I think companies that make the development of this critical verification information a priority, I think will thrive in the long run because they'll be more reliable. And yes, maybe they'll move a little bit slower in this phase rather than some of their competitors. But, at some point, these things, as we've seen with some of the recent events, eventually bubble to the top and people become very concerned about them. And that's why your investment in verification, your investment in crypto infrastructure might be really critical.
That's super interesting. One tagline we have for this show is we call it digital intelligence needs digital institutions. So you could say, the economy always had a verification loop. So when humans were the primary generators, then you had like human institutions, which were kind of like the verification layer in various senses. I think one thing that would be really helpful for us to unpack here is the scope of the different things that you mean by the word verification, right? Because I think it's itself heterogeneous. It has various types of things. There is execution verification, that this code executed as that this piece of code ran. But you also want outcome verification, whether the outcome actually made the impact. You want guardrail verification. There's all kinds of things I think you mean here. It'd be great to know your taxonomy of this.
Yes, let me start with one step before verification so that we can kind of build it up from first principles. In the model, essentially, we start from one basic assumption that you have to buy into, which is anything that can be measured, anything that has a digital trail that is being recorded somewhere can be automated. I think probably the best recent example of this is self-driving. For the longest time, right, self-driving seemed like something that very hard to complete at many nines of precision. But now that, cars are accumulating miles and miles every day, it's definitely within reach. So you can think of self-driving as a measurement problem. Once we had enough vision, enough information recorded through sensors or not, we can reproduce a human driving a car with high fidelity. So if you've ever seen, recently a Waymo or a Tesla with FSD, it looks and feels like a human driver. We kind of replicated that behavior. In fact, to some extent, they're probably safer than many humans on the road at the moment. So if you believe that that's true, and that's going to be replicated throughout the economy, then it's very clear that measurability is a really important dimension. And measurability really divides and forks between what we can measure as humans, and of course, our cognitive capabilities, our intelligence is still different than the new alien intelligence that we're growing with these models. There's going to be some things that we're better at measuring and understanding. Often it's because, look, since you were born, you kind of measured things subconsciously, right? You've seen events, you've made decision. You've seen causality in action. Professionally, you've probably seen instances of a certain problem and kind of what the edge cases and those out of distribution events look like. The whole difference between kind of a junior employee and a senior one is like the senior is just seeing more things, and they're calibrated, right? Whether they're a doctor or an engineer, they can look at the same evidence than a junior and make a completely different decision. Maybe because they're weighting past experience in a different way, right? So the weights in their brain are different than the junior. They've achieved some level of mastery. But agents also have measurability, right? So they've learned everything that's on the web. They've read every book. They've been fed all sort of interesting proprietary data. There are things that a human cannot keep in their brain that the agent can. And so you have on one side what the agent can measure, and on the other side what we can measure. And of course, there's a ton of overlap. And that's why I think people are feeling increasingly that the term AGI is almost like pointless. It is clear that we're going to have near AGI really soon, and probably some flavor of AGI. The two intelligence won't be exactly the same, right? So there's still going to be some differences. You already see it, right? Some of these agents are way more capable than us at some things, and then they fall flat, if you ask them to write a funny joke. In that gap lies the problem. And this is where verification is really born. In the area where the agent can do things, but we cannot fully verify them, we kind of have to trust the agent. And it's pointless to ask the agent to verify itself. I think we're going to use all sort of AI to verify AI when things are measurable. But when things are kind of not measurable by us, things get a little bit more dicey. And sure, you may get lucky and the agent may do the right thing kind of out of the box, maybe because it learned some principle of physics that turn out to be the ones we want, but it may also not do. And I think we've seen historically instances where these models were trained and developed some really weird alien preferences that had nothing to do with the original human intent. So why do you need verification? Essentially, the process of verification is making sure that whatever the agent has done and that the agent has measured and delivered on is sort of in line with your original intent and instructions. Why do you need a human in the loop? Is because essentially the human will have other measurement weights in their brain and will apply them to the output and decide, this sounds plausible, but actually if you read through the logic of what you just written, doesn't make any sense. I'm sure many of you have had that experience where you have a conversation with an LLM, they generate something that's totally plausible, and at first maybe you even believe it. You read it, it's like, okay, this makes sense to them. There's that moment where it's like, wait a second, and then you ask a very simple question to the LLM, and the LLM is like, oh, sorry, you're absolutely right. This is completely absurd. We should definitely correct that. That is the moment of verification. That is the moment where you as a human, with all your unique experience that you have accumulated over a lifetime, look at the output of the agent and decide, is this what it really intended versus not? Now, the challenge is that the things that are great with LLMs today are things where verification is super easy. You ask it to generate a picture, well, maybe you'll miss, okay, did it generate 5 fingers versus 4, which it's a thing of the past anyways. But verification of an image is extremely fast and cheap. But when you think about a code base, it gets unruly, right? So it could be millions of lines of code that now you're relying on. And unless you have the right tooling to kind of ask the right questions and almost apply a layer of meta verification instead of just reading every line, you're not going to get yourself out of that verification bottleneck.
Yeah, it seems like we've passed this automation verification flippening, right? Where the cost to do something and the cost to verify, I think you have variables for all of this in your paper. The cost to do something versus the cost to verify is that for the first time, for many of these tasks, the cost to verify can actually be higher than the cost to generate. The first time I had an experiential realization of this was generating AI songs, right? Like on Suno. And it generates a song in 3 to 5 seconds, right? And I was just thinking, it's simply impossible for a human to generate a 10-minute song in 3 seconds. This is just this is not a thing, right? And that is but now of course it's all bits, so you can generate any number of songs in a second. And so this flippening, I think, because that's the kind of the background on top of which the relative importance of doing something versus verifying is shifting to actually it did it, is it good, is it correct? The other model that comes to mind is the kind of the most important problem in computer science is there's these two, for the readers, for the listeners who may not be aware, there is the complexity class of P, which is things that can be executed in polynomial time, and NP, which is things that are non-deterministically verifiable in polynomial time, but basically just verifiable in polynomial time. And so these two classes, are they the same or not? And I think like a lot of what we are seeing in AI is, as long as you have a verifier, it can take enough tries to actually satisfy the problem. And I think one thing you mentioned here, which is very interesting, is about why humans may have an edge in verification. And I think you're phrasing in terms of experience as a way to prevent tail errors, right? Like, if so, this is reminds me of Ray Dalio sometime back had a, a, a model where he was saying basically that AI-based trading is not going to do well when you're seeing an 80-year cycle, right? Like this is not a cycle for which you are having millions of data points. There is like 3 times something like this has ever happened, and you have to generate a very different resolution of causal models. And I see echoes of that in what you're saying.
100%.
Out of distribution.
Yeah, and look, I mean, to some extent, we've been selected as an intelligence through exactly that kind of environment where things could drastically change in a way that nobody had seen in that generation or even previous ones, and we still adapted. And the survival requirement was pretty strict. For these models, it's completely different, right? They're optimized in a completely different way. So it is a different form of intelligence. We are very flexible, but of course, we're also very flawed on other dimensions. I think you're absolutely right. So, and if you take it to the extreme on the verification frontier, in the very end, what's left is going to be our preferences. Like, forget if the model can do everything and can measure everything we can, then it's just, okay, we have human preferences and they may develop their own. Are those in agreement or are those clashing? The last level of verification would be the one where, okay, this is perfectly fine output, but is it kind of siding more for the side of the agent or is it siding more for the side of the humans? My sense is that the only way out of that conundrum is going to be human augmentation. We will have to kind of blend ourselves with the intelligence we created in a way that, in a sense, it doesn't matter, it's us or them. We're going to be one and the same and hopefully better because of it.
That's super interesting. One thing I like, as you were mentioning this, the AI AGI problem and like the verification problem and how like things like blockchains could potentially play a role. You also mentioned on a separate axis how humans have a unique vantage point into verification and this historic thing. One thing that comes to mind is I was just, as part of preparing for this talk, I was going over some of your earlier papers. I found a 2017 HBR review that you had written on how blockchain applications will move beyond finance. And, I'll just read this quote. I was fascinated.
Oh, no. 2017 is a long time ago. I'm probably 100% wrong. So
no, it seems
yes,
like
the internet is forever.
The quote seems to be written for 2030. A seminal work on the theory of the firm, Michael Jensen and William Meckling, defined the firm as a nexus of contracts. The idea that firms are nothing more than a collection of contracts between various parties, employees, customers, shareholders. Right? Cryptocurrencies, I think you mean blockchains broadly, may one day enable a completely new type of organization by allowing us to securely transfer value and allocate resources through smart contracts. Whereas this new type of organization may achieve the speed and efficiency of a spot market, may be able to replicate the complex forms of governance required to execute the complex tasks that take place within the boundaries of a firm. And here's the last line. It says, combined with the advances in machine learning, we were already talking about AGI at that time, combined with advances in machine learning, this breakthrough technology will shape the flow of capital, labor, and ideas for decades to come. I think it's pretty prescient for like because I think the foundations of these technologies have not changed. AI as like accelerating innovation and intelligence and, blockchains, systems of verifiability, systems of enforcement, self-enforcing contracts. And those two have this complementary position. You've been thinking about these themes for quite some time. And, I find like echoes of this. For example, another paper where you compare machine intelligence versus human judgment. in venture financing, right? Things like that. So you've been thinking about this question of, I think the three pieces in my mind are AI, blockchain's other verifiability technology, and human judgment. And that this echoes like so many years back. I just wanted to like
Just very slow. Some of these ideas, take a long time.
Shriram, did you mention it was in 2017, this paper?
That's right.
I mean, so that's actually very visionary. The technologists were not even there, like most of them. They were like some rudimentary form. So like, it's really great.
It is really interesting. I found myself, I think, in a similar, I think it's 2017, in the working on some biology thing, and we were using mathematical methods.
Yeah.
And then one of my students came and said, no, just put AI neural networks on top of it, and then it's just going to solve it. I thought it's a ridiculous idea, but it actually did. It was better than my solution. It was kind of like pretty embarrassing. And,
so your AlphaGo moment was a long time ago.
Yeah, it was pretty close to the AlphaGo moment itself, which was, I think, around then. And I think from then, I've had this deep feeling that, oh my God, I'm losing my job. These AIs are here. We need to build things that'll have a durability beyond that time. And one of the reasons I got into blockchains. But I would love to learn from you how these distinct pieces have emerged and adapted over this, let's say the last 10 years that you've been thinking about.
Look, I think right now it's kind of fashionable to say that, people should move out of crypto and into AI. I mean, everybody's moving into AI. It's like, it's like the internet, right? It is not even a sector. We will all use AI for everything, so it's kind of pointless. But if anything, I'm more convinced than ever that we went on this long detour within crypto with a lot of mistakes, a lot of meme coins and token obsessions that probably didn't create a lot of value and speculation, to kind of build the foundational primitives and the infrastructure that AI will need for a number of reasons. It's almost like crypto is the industry for the side effects of AI. When you start with what it will do to identity, the identity ecosystem we have in the wild, it's just not ready. And I think over the next few months, we're probably a few iterations away from these models, or even people becoming clever about them in a way that will break essentially every digital platform, every government process, everything that used to rely on the idea that being a human versus being a bot was kind of hard, was distinguishable. I think we'll need a completely new revamp of that. And when it comes to verification, I think we'll need to go deeper, right? So we'll need almost like a supply chain with integrity for any digital flow. How is this information generated? Can we trust it? Where was this picture taken? Is it actually a real picture? Like all of these pieces, I think, are going to come useful over the next little while. And then if you're entering an economy where machine-to-machine interactions and commerce and payments will be important, because they'll be moving at a speed that we cannot even comprehend. Right? Yeah, I mean, you'll need crypto primitives for all of that. Now, how this comes into place, I think, is probably a little bit different than some people imagine, where it's like, oh, we need agents for agentic commerce to book me a flight and a vacation. I think for those use cases that are kind of well understood, look, a collaboration between a large payment service provider and a model company, you get like 90% of the value. Or a credit card company, the incumbents have the advantage. So everything that is known, I think, is going to go the route of least resistance. People love their cards. People love their banking accounts and the current flows. But anything that it's new, wild, unpredictable, and kind of agent first, I think will gravitate towards crypto primitives. So it is a really fascinating time to think through this. I don't think even the piece that you read could have predicted just how much these two technologies would converge. But I do think there's a pretty unexplored area. There's been some hype around, the intersection of crypto and AI, but often it's still kind of early crypto is always like this, right? So there's a lot of good narratives, there's a lot of meme coins and kind of pumps, but there's not a lot of value delivered. It could change drastically. So I could see us 6 months from now saying all these core protocols that were built for this purpose now are essential because AI just broke X, Y, and Z in the economy.
Well, just summarizing that, I think one thing that a lot of crypto people talked about early on, but hasn't really manifested, is the provenance verification. Things like digital media, right? Like what is real, what is, AI generated. So this is the deep fake related things. So that's one category of verification that, the blockchain technologies can play a big role, from sensor integrity to timestamping to transformations done on this thing, like all these kinds of things. On the other side, there is the issue of how do you identify an agent as an actor? Is it Christian's like personal agent? Is this like a kind of like a agent that's operating on behalf of a community or a collective? Is this an agent that is self-sovereign, it's doing its own thing, or its own company or something? Like there are these grades of agents, and each of them probably have a different kind of identity system. So if you're somebody's assistant agent, you need to probably get their digital signature and then have some authentication that is assigned to you. But if you are a community's agent, maybe like a smart contract gives you the rights and attestations that you carry along. Maybe if you're a self-sovereign agent, you need a identity system, which is, to know a person, you may need to know their brain and their DNA and like all these things. And so there may be something similar where you say, here is an agent, the agent has this, runs this code, uses these interfaces, only authenticated data, whatever set of things to create a kind of like a verifiable agent. So a bunch of those are core primitives. And I think you've elaborated in your earlier discussions, even other things like insurance, right? So for example, if I want to insure against certain things, new kinds of insurance markets. This was one of the things crypto people talked about earlier, but insurance markets are already pretty deep, liquid. And I think one more mental model you're presenting here is on the newer things that haven't yet existed. Blockchain native solutions can actually find an edge, which existing solutions don't have. So I think the space is rich, but I think you're also pointing out that specifically which combinations of these things take off in which applications, that is emergent and unpredictable. And that's where kind of like entrepreneurs, founders, academics at the edge of knowledge have to go and discover it. Just to summarize what we've discussed.
Yeah, and look, I think that process of going on the edge and discovering has never been more fun, right? So the paper is not a doomer paper. There are some concerns, right, in the paper where we talk about where things will go off the rails if we don't pay attention to. But it also surfaces the idea that every one of us now has essentially the tools that we would have dreamed of even a few years ago. So when you talk about going out and experimenting and exploring these ideas, every single individual now has the power of a startup, right? So they can launch a swarm, they can test hypotheses, they can learn from the market, and that cycle is going to be a lot faster. It is also where the infrastructure is probably, still early. I think there's a lot of enthusiasm around open cloud, people tinkering with these systems. The security is definitely not there. And coming from crypto with an adversarial mindset, it's very easy to imagine, what needs to happen for this to become really, the bedrock of an agentic future. I do think that if you zoom out, crypto founders and people building in crypto should really actively think about, they're in the business of verification. Our industry sells verification. The famous trust but verify quote that's been reused many times also by the crypto crowd.
Yeah.
That's all we built, right? In the end, when you think about even back to basics, right? When you think about Bitcoin is essentially verification. There's some fixed supply, and it's very easy to verify that you own a piece of this new digital asset. Similar with agent identity. I think there's been some really interesting and thoughtful proposals. For example, Amir and Craig over at Skyfire have been trying to propose this idea of know your agent, right? How do you give an agent an identity and credentials, right? So that it's not seen as a bot, it can act on behalf of a customer. And I think if you put together all the protocols that different companies have put out, from Google has a bunch of these and others, eventually we'll be in a regime where agents will be the biggest share of the economy. They'll do most of the transactions. They'll be delegates of humans or of corporations, but they'll be interacting at a high frequency with, decentralized and neutral protocols. I just don't see this all landing on a single, network. And that's where, again, the neutrality of what's being built in crypto, I think, will really shine. We will need to preserve that. Otherwise, you're creating a super centralized system that can have all sort of side effects.
Right. The decentralization or credible neutrality also leads to levels of permissionlessness that anybody can come and build and improve and augment and compose with these systems that has a faster rate of growth and takeoff than the more gate-kept garden cathedral approach.
I mean, you're seeing it, right? When New York is trying to ban people from using LLMs for legal advice, it's like, come on, we have open source models, we have potentially also decentralized inference. People will work around and will find their intelligence. And the guilds, I don't think will be able to stop this.
That's it.
Now, again, sometimes the advice is not perfect, but
Right.
on average, it's better than maybe what many people would have access to or be able to afford. So it's a massive equalizer that we should actually embrace.
So one thing on this agent side, like agents using the blockchain, many people think that you will have only personal agents, and why do you need a verifiable infrastructure? It's just supporting your own needs. So what kind of agents are agent use cases where this verifiable infrastructure becomes paramount?
I think the moment you essentially need to trust an agent, even for personal reasons, you need verification, right? So at some point, some agent will do something nefarious or wrong, and can you stand behind it? Again, I think people are not thinking through these issues because they haven't emerged, but very soon some of these open cloud will do things that people will regret, maybe even something illegal. So I do think verification will be important throughout. But more importantly, as you scale up it's almost like the different levels of self-driving autonomy, right? At some point, agents will coordinate resources, and maybe we will get to the quote there in the firms as next is a contract where the agent is the director of a company or an enterprise. I don't think we're there yet. And for the next little while, I think humans will be the intent directors. And maybe a single human, as we describe in the paper, will be able to kind of deliver what we coined the AI sandwich, which is a bit of a throwback at the stablecoin sandwich for those deep in crypto, where essentially you have a human director at the top that sets intent, sets the purpose of the venture. You have a middle layer of agents executing at a very low cost. And then you have a bottom layer of verifiers, top people that will decide, okay, is this what we're actually going to ship?
So this is like a sandwich between.
Correct. The agents are sandwiched between humans for now.
That's very
But I guess you could also do the opposite, right? Maybe it's like, humans execute in the real world until we have robots. Agents direct and agents verify that the human is actually doing what it's supposed to be doing.
So one question or counterpoint to the verification bottleneck is, if you take humans as a collective, right? Who's verifying that we are doing anything good, right? So it's in some sense, I think the answer to this is in some sense.
It's the oldest problems in the world, right? Which is essentially a principal is delegating someone to do something, right? The classic principal agent problem.
Right.
Is the agent doing what it was instructed to do? Yes, it's not an agent only problem.
No, for sure.
Yeah.
No, there's the delegation issue is, which you're pointing out that it's always been there when you have a company and you delegate it, or you're a king and you delegate it to a minister and so on. But I was also asking as a kind of like a meta thing, the constraint that you're operating under, which is that agents are the verification problem for like agents as a new species or a new like class, right? Like if you think of that same problem for humans as a class, like think of who's verifying humans' work and is it any good? And I think the best answer we have is the market judges its relative value and allots the thing back. Why do you think the market is insufficient as a mechanism for agents to be verified? The outcome or quality or output, like we were just talking about AWS, and you said like, it's not in AWS's interest to ship slop, because if they ship slop code, their token price, their share price is going to go down. And so they have self-selected or evolved to not do that, right? And so are course correct against that. Why wouldn't similar mechanisms eventually regularize agents, even without, because I think right now I see like a lot of the use cases are indexed around there's a human intent that the agent's executing, then of course you need to close the loop to verify that the intent was executed correctly. But as a society, like there is no specific intent. There's just like the market that mediates all intent interactions to happen. And so I'm just wondering if I just take the limit of the 20-year period, then does this verification problem just be solved by agents having like, being their own economic actors, or like being regularized by being the economic actor regularizes itself? Because if you're doing bad stuff, you get evolved out. If you're doing good stuff, you get like evolved up. And by using some kind of bitter pill, bitter lesson thing where like you have millions, billions of these things learning, you just like solve these problems.
So this is like a market as a super intelligence filtering out
Yeah,
the bad
as a
data.
filter.
Intelligent
Market
verifier,
as a filter, yeah.
Yeah.
Look, essentially, no, that's an excellent question. And essentially, you have to believe that right now we're facing what economists call an externality. Why does it need to be an externality around verification? It needs to be something where the private entity does not fully internalize the cost that it's creating on society. Let me give you a specific example, and I agree with you at scale, the problem is much less severe. The problem is essentially during the acceleration and the ramp-up phase. Take the foundational models as a good example. Right now, they're in a race. So they could decide to invest more in safety and alignment and delay the timeline a little bit, or they could ship and hope for the best. Because they're in a race, like you already pointed out, it's a prisoner's dilemma, and so the dynamics are really not driving in the right direction. But the bigger externality is that sometimes, again, the effects of these models on society could be so tangential to the business that they're not fully internalized. And yes, some could be company ending, but some could be not. And more broadly, when you think about it, it's similar in blockchains with security. Improvement in security, everybody benefits from them. And so if any one of the players, including a company that's building on these models, were to invest more in security and verification, inevitably some of what they create will probably be public knowledge. That's actually kind of a classic case for where the government should be investing in, white hat kind of activities and development of open source models and contributing to the community and making sure that there's funding for open source and for all of this. It's a bit like the antibodies. Security is something we all benefit from. Steering, alignment, all things that we all benefit from, and private actors are not fully appropriating it, and so inevitably they're going to underinvest. But I think you're right. At scale, once we get out of the bumpy moment, as things really pick up, the market will say, okay, this is a good AI company. They take account of essentially the liability as a software model that we describe in the paper. This one is not, and weed that one out. I do think the challenge right now is that because everybody is running, by the time we discover that, we may have created a problem that's probably too big to be undone. And that's kind of the hollow economy scenario that we describe in the paper.
So interestingly, on this acceleration phase, you mentioned that the private actors might not invest, they might reap the benefits, but as a society, we all face the externality. So that externality means not investing on the verification infrastructure, for example. And right now, the way in this acceleration for the labor market is going on, companies are investing on cloud agents, getting more and more, and like laying off more humans. And so that creates a cycle where the humans are not getting experience for what does verification means. It will be like a lost knowledge. Like for 1 year, 2 year, if we see this cycle, all this might start looking in magic, the whole infrastructure. And at that point in time, what might happen is that if there is enough layoff and all, like AI's impact shows up in the labor market, government might step in. So is the pill for this externality is government stepping into the whole market as a major player and removing the free market dynamics itself, like forcing everyone to build the infrastructure? Is that the solution here? Because even
I hope not. I hope not.
Because if the investors are also in a Keynesian beauty contest, I missed the investment in runway model, let me invest in some other video models where I can invest and get my benefits. Like investors are also thinking in those terms, right? Everyone is looking how to make money from this automation, like this acceleration phase where automation is going.
Look, governments tend to be very inefficient and imprecise when they try to do something. So they should only be used when there's every other tool has kind of failed. I think their government intervention and policies are much better at setting the right playing field so that the right outcomes arise. And I think there's a lot here that could be done. Take some of the challenges that we talk about in the paper around the labor market. We label them in two ways. One we call the missing junior loop. So the idea that juniors will not land that internship that kind of builds their expertise or used to build their expertise, and they may not find that first job. So we need tooling to get them to mastery even without a job, or we have to reinvent education to get them there. And then there's the codifier's curse, which is the opposite. So you have very senior talent. I think the best example is recently when Claude released tooling for cybersecurity, for testing systems against security flaws. That used to be a very, very selective, slice of the talent, and a lot of it is now being automated. Ironically, as we all work with these tools, we create the very labels that displace us. I mean, the early example were simple, right? People were labeling images. And of course, at some point, those companies didn't need anyone to label images anymore. But this is happening across all professions. In the labor market, if things move really rapidly, I think we will need to create almost like what is the new, educational treadmill that can on one side accelerate people to mastery and get them back on the frontier, even if they're already like mid-career or late in their career. They'll need to be retrained. They'll need to learn new skills. They'll need to learn new tools. How do we get that done? Some of that, of course, people are already doing, but eventually we'll need to have a proper answer for everyone. And second, how do we almost build these flight simulators for jobs, right? Which is, first of all, we're going to invent a ton of new jobs, but even for the ones that exist, how do we get someone that's not going to get that entry-level job to be, an IC6 or 7, right? If you want to talk in engineering terms. The first years are gone. In fact, companies are not hiring them. And yes, I mean, we've seen layoffs like the massive one at Block. Of course, that's a mix of tech bloat and AI opportunity. But, there's definitely AI opportunity in realizing I can run the same shop with a lot less people. And if that's true, then, you have a generation of computer scientists. I think the last few years have been the first years where computer science graduates didn't get jobs, right? In some universities, this has never happened before. And yes, I think we're going to hire a lot more computer scientists. The demand for software will explode. The Jevons paradox is going to be real in all of this, but there's still a training problem. And yeah, maybe it's going to be a mix of new startups building new educational tools, and maybe also the government supporting those startups in that ecosystem, so that we can all kind of rise to the occasion here.
So this is like a GI bill that government had after post World War II to upskill everyone as a technologist and scientist.
Very similar, right? Yeah, essentially you have a massive workforce that is facing this crisis. And look, the most entrepreneurial individuals are already doing it. They're already tinkering with all these tools. They're already trying things. But what's the answer for the rest of the population? And especially if we don't want at some point the Luddites to take over and, try to burn down the data centers. I mean, right now they're already trying to stop data center development. The tension is already there. Yeah, things could get pretty unruly.
So on this, the things can become unruly. So now what can happen is the automation tools are so good. Everyone can become an entrepreneur potentially. And I want to touch on that. If everyone becomes an entrepreneur, where do they get the capital? So you had this paper from 10 years back. It's like some simple economics of crowdfunding, where you mentioned that crowdfunded startups due to internet, it removes the geographical blockers for getting funding. Now, is that a similar dynamics that can happen with this model, where there is one person who is a director who has a lot of agents under that director, the human being a director here, and they can use internet for getting funding. In fact, we can extend it even further, that maybe we can have zero director companies, zero human director. It could be like an agent being a director. Can they do the fundraising via internet? Is that the scenario that is going to play out?
So something that's going to happen in the intermediate phase, and I think we're already seeing it, is that also with jobs, right? Because of AI slop, job posting get inundated with many more candidates. VCs and then angel investors get inundated with many more pitches. The pitches also look more good on average, so it becomes harder to tell, is this actually a good team or not at a first glance. In the past, probably, a good deck from a bad deck would be more salient. People are falling back to networks, connections, kind of all the old school stuff. And so it's almost like a non-democratizing force. And we're retreating to the strongest and higher signals on some of these things, including for jobs and for investing. I think as we build better measurement, as we build better verification infrastructure, an individual, no matter where they're born, they should be able to have a track record of what they build, what they can achieve. And that record eventually should be fundable, right? And if it's not fundable by traditional investors, it should be fundable through the internet. Again, crowdfunding, equity crowdfunding, but crypto in general have been great instruments for that. They've also been abused in the past, right? So I don't think we have a lot to show for projects that were kind of crowdfunded and eventually became major projects. But, even if you think about Ethereum started with a crowdfund. And so I do think we can build wonderful things on the internet if we create the right signals, the right reputation systems, the right verification infrastructure.
So in your paper, you mentioned about these strategies as an individual, as a firm, as a policymaker, as an investor, what we can take in this, especially in this acceleration phase, to ensure that we have this verifiable abundance. Instead of moving to hollow economy, we go to a verifiable abundance. You have some recipes. Can you elaborate on that for each of these class of characters, actors?
Yes, we didn't want the paper just to be, a theoretical model. And so, in fact, for many probably listening to this, section 8 and following are probably the most useful ones, where we try to take the model and come up with recipes, right? So what are the things that individuals, startups, incumbents, and in general investors and policymakers should really focus on? Really briefly on the individuals. The first one I think we already touched on, which is the idea that these are the tools for really achieving mastery, staying on the frontier, generating that synthetic practice in fundamentally new ways. So yes, AI makes some of our knowledge obsolete, some of our skills replaceable, and maybe we're also helping create, again, those labels that will displace our own role. But fundamentally, it also gives us superpowers. And so the first piece of advice is really take those superpowers and start building, whether it's in your hobbies, your professional life. I think people are a lot more creative than they give themselves credit to in their day-to-day jobs. And this is the technology that can really enable that. The second one for the individuals is kind of to realize that the orchestration architecture really can amplify your talent. We already talked about the sandwich, but it's true that in many professions, you can now focus on that thin layer of verification, that thin layer of steering and intent definition, and scale that up. So you can take on a lot more work and be a lot more ambitious than you were before. If none of that sounds like something you want to do, there's also parts of the economy that are fundamentally non-measurable. At the beginning, we talked about measurability, and there's all sort of sectors where measurability doesn't really matter. If you think about industries where human connection really matters, status, coordination games, status games, there's entire segments where, in a sense, humans care that other humans care about the same things. And if you're really good at that, and many of the creator economies already really focused on that, I think that's going to be an increasingly thriving piece of the economy, including all sort of experiences that people will seek when a lot of other stuff becomes really cheap and accessible through AI. But at a high level, everyone can go through their job and really think through which tasks of my job are measurable, replicable, automatable, which ones are kind of not measurable, linked to the judgment, those weights in my brain, right? My own experience, my own unique perspective on the universe, and me kind of channeling into the output that comes out. That's kind of really the key of this. And to some extent, of course, physical labor is more protected in this first wave, but robots, as we see every day, are not too far behind, even if a bit more bottlenecked, I think, on the supply side.
So one I have one pushback for the individual. So you mentioned that having this taste or something like that, the hard to measure trades. I want to draw an analogy to the industrialization, the first wave of industrialization that happened, where hand woven artifacts, which in developing countries like India, it's very cheap compared to manufactured goods. It's because of there is way too much labor, but surplus labor. But in developed countries, it's considered as premium, right? The handmade goods. So it seems like it's hard to tell that if as an individual I move to a sector where I'm doing tasks which is hard to verify, hard to automate, there's not explicitly a guarantee that I will accrue value. It depends on where you are. Isn't that like going to make the impact as an individual much harder? It's that geographically it might be very distributed.
For sure. I mean, the other reality of many of these non-measurable segments of the economy, including anything that has to do with status, coordination. I mean, think about art. They tend to be blockbuster sectors. So a tiny share takes on most of the rents. Now, of course, personalization will matter. And I think humans will pay for experiences where essentially what you're paying for is that you have the undivided attention of another human being for a certain moment. So again, it's gonna be not always good news, but I do think we're gonna invent a lot more jobs in this. And humans are really good at coming up with new status games and new jobs when some of the existing ones disappear. Right? There's all sorts of situations where groups of humans have found themselves in very difficult situations and essentially created a whole parallel economy within the constraints of the experience that they were living. So yeah, that's going to be one part. Maybe not the most interesting. I do think most of the upside will come from humans becoming kind of directors of agents and scaling up their creativity across all sort of sectors of the economy, right? So if you roll back the clock even a couple of decades, could you have imagined that many humans would be creators, kind of following their hobbies, following their passions, and having an audience of others following what they do, right? I guess that. So there's going to be more surprises like that and more new jobs of that type. For companies, I think things are slightly different, right? And yes, there's going to be some similarities, but I would say that verification infrastructure we've been talking about since the beginning of this podcast is probably the most important investment that every company can make, where you make that agentic risk legible to the firm, you make it measurable. You really think about adversarial verification at scale. How can you industrialize a system where agents take execution to the limit, but you're still in charge, you're still in control, you still have visibility and interpretability on what's going on? I think the companies that do that, they will naturally sell, again, this liability as software model. It's infinitely scalable, right? In a sense, many jobs that used to be labor will become software with the right guarantees, but you do need kind of that right type of information underlying your models so that you can kind of hit the target and not just miss it or accumulate technical debt. Another sector that I think is going to be quite interesting for startups and companies is what we call as ground truth as a moat in the paper. Every time you have information that's relevant, more precise, more fresh, you'll be able to deliver better results. Whether it's a data feed about the market or it's a data feed about public events, if you can ingest that before everybody else, if you have that proprietary knowledge, super valuable, right? And your agents can really scale. So again, I think it's going to be quite exciting for companies that maybe used to have proprietary data and didn't know how to really productize it. They maybe sold access to the data. They can now go all downstream and sell the entire workflow around that data. And then again, I think companies will also compete in the measurables. Some companies will push into deep tech, sectors that haven't been measured yet. So deep R&D and advanced technology where, again, things are not as well defined. And I think the main recipe for that is really think about these verification grade network effects. You want a product that every time you keep adding cycles, you get more precise, you get more reliable, you can beat the competition. So those are kind of some of the key elements. There's a lot more in the paper. For investors, I would say the playbook is even simpler, is essentially invest in the companies that follow the playbook that I just described. Invest in companies that really have this verification grade ground truth, that have that cryptographic and crypto infrastructure for verification. Companies that build that synthetic practice and can allow humans to stay on the frontier. I think there's going to be a massive demand for that. And then look at them, again, from a liability perspective. Are they shipping code that is underwritable? Are they shipping code that's safe and sound? Or are they taking shortcuts? I think that's kind of the bifurcation. And some of the best investments will be companies that do all of that. I think we already talked a lot about policy. There is an externality. I do think it's going to be a problem. Honestly, the best things the government can do is really ensuring that infrastructure like the crypto one, open networks, all these things around maybe decentralized identity and credentials can be supported and can be used. Of course, they should also invest in the white hats and making sure these models are really battle tested. You can never have enough testing, and probably academia should also play a big part on this, and funding for that could be really useful. But if you zoom out, maybe governments have two challenges. One is like this massive investment in human augmentation and upskilling. How do we keep the humans relevant? How do we make sure that most of society can still contribute to the economy? And the second one is, how do we avoid this race to the bottom geopolitically, right? We don't want anyone to deploy a model just out of rush towards AGI and then get us all paper clipped.
That's an amazing summary of like concrete things for different actors to play. Christian, can you walk us through this figure which maps the automation verification in various quadrants?
Yeah, so I mean, this is kind of a good summary of the entire paper, right? So we already talked about the two different cost curves. The cost of automation is coming down really rapidly. It's the one that really benefits from more compute, more data centers, more improvements in foundational models. That's the one accelerating like crazy. On the other side, we have the cost to verify that is bottlenecked by our biology, right? So by our human nature. Of course, if we augment ourselves, then to some extent, we're still benefiting from the same economics of the cost of automation. But for the moment, when you look at this, it really splits the economy into 4 zones. And ideally, we have less than a proportional division between these. So they don't need to be perfectly symmetrical like you see in the picture. The bottom left is the safe industrial zone. We can automate things, we can verify them. This is where AI is going to bring massive benefits to society. It will also displace a number of jobs, right? Because jobs that used to be in those quadrants will essentially end over to the machines. Then you have situations that are particularly worrisome where the cost to automate is not that high, but the cost to verify is, whether it's because it's economically not beneficial. We call this the runaway risk zone. These are situations where we might be very tempted to scale up things a bit too fast. And this is where we should be a little bit more careful. Now, why? Because as we discussed, if you do that, eventually you may pay a very steep price for that. Then you have, situations where both are high. We call this the pure tacit zone. Another definition for that is like the domains of unknown unknowns, where things change really rapidly. You had the example before about the markets, right? Regime change in a financial market, it's something that can be pretty drastic and very hard to predict. There might be cycles, there might not be cycles. This is a zone where, again, capabilities really need to improve for AI to make a dent. And I think humans still have an advantage. Now, with the development of word models, maybe some of this area will become less tacit and more understandable. The potential of word models, after all, is to be able to run all this simulation, understand causality, and really plan for the future. Maybe what are all the potential future financial scenarios that could come out of this moment with a war, for example, having just started. And then there's the kind of the artisan zone. Here is a zone where automation is hard, verification is easy. And so essentially this stays human mostly because the entropy of the task, the complexity of the task is still too high. And we still need better measurement to solve the problem. I would imagine, people often say plumbers will be a very good profession for the next little while. Again, in this zone, it's important to remember it all depends on measurement. As soon as you have enough measurements of plumbers fixing different fixtures in different homes, in different situations, a robot will also be able to automate that.
It seems like there is a progressive expansion of measurability. That's what's going to happen.
Yes, absolutely.
Yeah, it seems actually even inside firms, there is a lot of non-measurable things. You hire the right person and you hope like, okay, I got a marketing guy, let him do the thing. And whereas some companies which have been able to bring measurement inside of the companies actually like succeed much better because they have clear KPIs, they know what they're optimizing for, and people know very specific things that they need to do. So it does seem like inside this loosely knit companies where like, you put the right person and you hope their genius kind of like takes you to where you need versus you have tight measurement technologies. And I think so inside the economy, you see already like the gradient towards more measurability as a way of scaling, like even companies. So it's interesting to see this new object is basically bringing this lens of if you can measure it, I can optimize it, right? Like that is the whole power of machine learning, AI, agents, robots, all these things. So that's going to put even more pressure for making more of the economy measurable. So super interesting to see that. For our audience who we very strongly recommend, please go read this paper. It might seem too long for some of you. Plug it into your favorite LLM. You can ask it questions. You'll find a lot of useful information, and you can zoom into what is the most interesting things.
The models sometimes don't do a perfect job at summarizing it. I tried it myself. There's a few Easter eggs in the paper for the models themselves, so maybe your LLM will find them or not. What I would say is take a look at Section 8. I think you don't need to go through the 100+ pages, but Section 8, you can pick your category, whether you're an individual, a firm, an investor, or a policymaker, and then just read that. Or have that section summarized by your LLM.
Amazing. Thanks so much, Christian. This was super awesome walking through the paper, but also different ramifications and how it intersects with some of our common interests here. Before we conclude the show, do you have, what are the new things you are excited about, thinking about, working on? Anything you want to convey to our audience before we sign off?
Well, The last big sprint was really developing the model and kind of getting to have a better understanding of where this is all going. So I would love for anyone listening to this podcast and reading the paper, very easy to find on X at C Catalini. Send your feedback, send your ideas, tell us where we were wrong. That's going to be really useful for the next phase. For me, the next phase is really all about, serendipitous conversations and interactions and trying to understand, in a near AGI world, what's really worth building. What should we be building for society to really have an impact? That's kind of what I'm focused on right now.
Amazing. Thanks so much, Christian. It was a real pleasure to have you here on the podcast. Soubhik, anything to sign off?
Just before signing off, just want to recap. So we covered what it means, how is AI going to impact the society, the labor market, the policy making, capital for flow. And as for that, we covered first, what is the hollow economy? There is two bifurcation. The first is hollow economy. And the second one is how, if we want to avoid hollow economy, if we want to go to the verifiable abundance, what are the steps we as a society should undertake? It was great discussion. So thanks, Christian, for coming to the show.
Thank you both for spending so much time with the paper and the wonderful questions and conversation. Really enjoyed it.
Amazing. Thank you.